Okay, so for this independent study, I intended to use lecture videos plus self-study. So I believe you are quite familiar with most of the materials, so you can learn by yourself for most of those things. So for me, I will mention some important issue, important points, or difficult ones in my lecture videos. Okay, and I believe probability. So this course is about probability and statistics. So probability itself is useful and important. So I hope you can, after taking this class, I hope you can consider to take actual exam P1. Then I try to be actually, and then you can maybe can find a good job. Okay, so let's see. Yeah, you maybe can consider us. So P1 is just a probability. Okay. Okay. So let's check the contents of this textbook. So I already sent you this free textbook. I already sent this book to you, right? So let's go to contents. Okay. Okay. So our first class, we also can see on the overview. We also can see overview of the course. Okay. So here, let's say like we say that this is about statistics, probability, and stats. So why those two things are related so closely? Because we say the language of statistics is probability. We use probability language in statistics. So in stats, we have to use probability, right? So for probability, we are quite familiar with, right? So probability, how to find a probability? So we say probability A is just equal N A N T. So this find probability PA. We just check how many NT means total numbers, how many total, and how many for this case for A, right? So many probability problem is just focus on how to count, how to find NA, how to find NT, right? So we will use some counting method. So those counting method usually is permutation and combination, right? Okay. So find the probability. Basic idea is separation. We say separate all into parts. Okay, okay. So we can have the probability, like take some probability from this part, right? Or from this part, we can have such problem, right? We can have those probability problem. So if we just consider these typical parts, then such a probability is just a conditional probability. Conditional probability means we just focus on this part, not for all. Okay, so here we can separate all people by one fact, or two fact, or like we say, we can split people by two variables. For example, we can split people by gender, right? So we have male, female, right? We can split all into this. There's two parts, and we also can split people by grades, like split students we're talking about. Okay. Grades. So we can write some people A, some B, some C, some D, like that, right? Okay. So here we split the people by two things. So we can consider those things. Is those two things related or not so related? So we introduce this notation, independence, right? So what is independence? So in general, we can use this notation based on probability. We say probability for this thing happening, like under this condition, under condition B, equal this probability like under not B, like B or not B, same, or we can say this equal, just equal PA. So if this is true, then B or not B doesn't matter for A, right? So we say AB. So there's a definition for AB independent. AB, those two things are independent. These two things are not related, like no relationship, we also say, right? AB are independent. Okay. So for probability, we can like probability for this thing, this case, probability is this. For that case, probability. Okay. So for probability, we can have like probability for case 1, or what is the chance this case 1 happen, case 2 happen, or case 3 happen. So if we put them together, like case 1, or we say case 1 probability is P1, or case 2 probability P2, like we saw, we put it together, those are distribution, right? So case 1, case 2, so usually we use this notation, like we use a landing variable with x. This thing equal 1 means case 1, like case 2, right? So probabilities of each case, so P1, P2, okay, P3, okay. So those are distribution. Okay. So from this distribution, we can define these things, expected value, right? So expected value, we denote this as x. So expected value, those things that come from gambling, right? You can win this number, you can win that number, or you may lose that number. So expected value is on the average, how much you can expect to win. Okay. So we say like this expectation is not this expectation value. These things is important. Like if the x is positive, then this means you can win money. If this x expected value is negative, this means you will lose money, right? Okay, and so this is x expected value. So in general, we can consider xk, right? Xk. So we call those as a moment. Okay, and then from related moments, we related all these moments, we have this moment generating function. Okay, so then we consider some typical important discrete distribution. So those are binomial distribution and Poisson distribution, right? So for those two distributions, we just remember this. When we have a binomial distribution, we just like try in times. So how many times you can success? So those things binomial distribution. So Poisson distributions in a certain time period, like this time, how many something happen, number of happening. Like in 1 month or in 1 week, how many car accidents happens, right? Or in one hour, how many phone calls will come? So those are Poisson distribution. Okay. Okay. So then we have a continuous distribution. Right, continuous distribution. So most important continuous distribution, normal distribution. So where normal distribution come from? So we say most things normal, just the most people just on the average, right? So this is normal. Only very few on both sides. So this is normal distribution. So we are quite familiar with this, right? So this is okay. So we say this sentence is just the mean or expected value. Okay. And so normal distribution in terms of mathematics, we say this function is just like negative x squared. Suppose this is 0, right? So in negative x squared, as this function goes down on both sides, right? Okay. So use. So how about those things like negative x squared or multiply? Here I have some like a polynomial function, like suppose like x times negative x squared, or here negative x. If we use the substitution, we just let x squared as t. Then this x become a t half, right? Also in general we have this like x some power, x alpha, or we also can little bit generally x alpha is negative beta x. So those distribution we call gamma distribution. Okay, gamma distribution. Okay. So we find that normal distribution can be regarded a typical gamma distribution. We can change after some substitution, right? So from mathematical point of view, this is more general, like just this those functions will come, just exponential functions. So by the way, if we just have this and no polynomial function, so we call this an exponential distribution. So this actually is also important, exponential. So we also have exponential distribution, gamma distribution, normal distribution. And so from mathematical point of view, we have many continuous distribution, right? Because we have many those functions. Okay. Okay. So for continuous distribution, so we also have those things, so expected value or moment generating function, those things, moment. So find the expected value or find a moment. So for continuous distribution, so we need some calculus, right? Okay. Okay, so this is we say for one variable. So one variable distribution, we have one variable discrete distribution or one variable continuous distribution. Okay, so for two variables, we call those distribution joint distribution. So for joint distribution, we also have a discrete situation, discrete distribution and a continuous distribution. So for discrete distribution, so we can use this really we can use this really easy example. X can be like can be 1, 2, 3. Y can be 1, 2. Okay. Then we have those probabilities. So this is a joint distribution. Okay. So if we have two variables, so we can consider this correlation. So this correlation is a measurement to check whether this X and Y related or whether there are no relation. So we also can say like if correlation, let's say CORXY equals 0, we also can say X and Y are independent. So for independence, we have two definitions. One is conditional probability with like this, like all X under Y and not under Y is the same. Then we say Y and X are independent. So other different definitions are correlation of X and Y equals 0, then they are independent. So here we have a natural question. So the two definitions are exactly the same. So answer is almost the same, but not exactly. Okay, not exactly. Like not exactly means correlation equals 0, but according to first definition, the probability not equal. Okay, but anyway, like here correlation is just judge whether there's two variables have some uh, uh, two variables are related. Okay. Okay. So if we have two variables, then we can have those conditional distributions. So here, conditional distributions, we just focus on, we just fix x, so we have those like y. We just check y's. Y can change. Y can be 1 or 2, right? But here we just fix x, just this case, x equal 1. So when x equal 1, y can be 1 or 2. But the probability, so probability is this. So those are just we say the conditional distribution y under this condition. So for this conditional distributions, we can find expectation, right? So such as those expectations is called conditional expectation. Okay. So for discrete situations, those things are really easy. For continuous distributions or those problems, those things become not so easy because it involves two variables integration, like so a multiple integration. Okay. But anyway, so here, so we only can check some very typical, so normal, now we typical situation bivariate normal distribution. Okay, so this bi means two variables, so x, y. X, if we fix y, x is normal. Fix x, y normal. So together, those are also normal. So for bivariate normal distribution, we will check this correlation, right? Yeah. Or whether it's x and y, if both of them are normal, so these two normal are independent or dependent. Okay. Okay. So if we have two variables for continuous situation, we say become tough because we need a double integration. Or if we have three variables, we need a triple integration. So too complicated, right? So sometimes, so here for many multiple random variables, we can consider some transformations of that. We can consider some typical situation, like we have three variables, x1, x2, x3. So sometimes we focus on this, like how about x1 plus x2 plus x3? How about the distribution for this t? So t is one variable, right? So sometimes we will consider those kind of problems. So there's transformations of multiple random variables. So if we have many variables like x1, x2, x3, so sometimes we can consider that. Sometimes we can consider the largest one. We can consider maximum of x1, x2, x3. So those, or we also can call this the largest. So those things is all the statistics. because so like let's say like in data, suppose we have many numbers. So sometimes we just focus on largest one, right? If we have two classes, sometimes you just compare largest one. So those focus on largest ones, those is just all the statistics. Okay. We from x, if we have a in x, x1, x2, xn, so we sometimes we will focus on their average, like also focus on their largest one or smallest one, minimum one. So all those are called all the statistics. Okay. So here, chapter 6, statistics and sampling distribution. So here, this actually statistics distribution and sampling distribution. Okay, here should be like a statistical distribution. So, we, I believe we already know. After taking some stats course, we usually need Z table, T table, F table, chi-square table, right? So those tables is related to those distribution. Like we have normal distribution or chi-square distribution or chi-square distribution, T distribution, and F distributions. Okay, and sampling distribution usually meanings like x bar. If we take a sample, we have like many x1, x2, like we have x1, x2, xn. We have many. Then we focus on the average. So we have this result. The average will follow normal distribution, right? So this is really important, and this is just called central limit salient. So in stats course, we just use this result. So in mathematical statistics, so here maybe we will focus on, we will try to prove. Okay. Okay. So all those things so far, we can say those are the probability issue. Okay, probability issue. Okay. Then chapter 7 go to statistics, right? Okay. So for statistics or first question, if we have data, like we have x1, we have data, then we want to do some estimation. Like let's say, like for population, we say so stats is why we need statistics. Why we need statistics? Because we want to get some information about the population. Okay, so for population information, for population, most important is the average, right? Mu and or sigma, the standard deviation. Like for if we have many people, we will check the average and those standard deviation. So standard deviation, we can understand the difference between people, among people, between people to people, they have some difference, right? If sigma equals 0, so meanings those people no difference. Okay, so sigma just measures difference. So those things we don't know, mu, sigma, we don't know. So how can we estimate them? So we see we just take a sample, right? So take a sample, so we have those data. So from the data, from the sample, we can find those like average x bar or sample mean and sample standard deviation. So instead, we say we just use this to estimate mu samples mean, to estimate population mean, or sample standard deviation to estimate the population standard deviation, right? So this is a very natural way. So, but we do not ask why, right? Why we can use x bar to estimate mu? So instead, we say we never ask why. So here we will ask why. So at first, let's say, if suppose we want to estimate this mu, so you say use x bar. So how can find this way, like x bar equals this, like we say we have data x1 plus x2. So data is x1, x2, x3, x those data. So you say you give me this formula. Oh, how to estimate this mu? You say use this number, right? Use this number to estimate this mu. So here we have this question: how can you find this? How can you get this formula, this method? So this is like we say how to find a way, a formula to estimate. So here we say we have this method by moments or by maximum likelihood. So maximum likelihood meanings those like we can use this number, we can use that number, but this we can use A or we can use B. But it seems like B is more likely, right? Then we should choose B, right? Okay, so such a method we call maximum based on this likelihood. And the other way is so you okay. So you say how to estimate this mu. So you say you can we can use x bar. But we also will ask, no, x bar is a good estimate. Do we have even better one? Or how can is this one the best one? No, x bar is the best estimate. Best estimate for mu. So for this question, instead, we never ask, right? We just say, oh, use x bar, use sample mean to estimate population mean. We never ask why, or never ask whether this is the best one or not the best one. If this is not the best one, we try to find the best one, right? So here we wanted to prove this is the best one. So we introduce this sufficiency and efficiency. Means from those information, so like x1 plus x2, those things is sufficient for estimate mu. We don't need to use other information because this is sufficient. Other information, for example, we have like we can use x1 square or those information. So sufficient means simply say we don't need those information because this one information is enough. Okay, this is sufficient. Or efficient. Efficiency means use this efficient. So usually sufficient and efficient meanings the best. Okay. So those are the point estimation. But instead we perform like how to find mu. You say, oh, mu the class average is let's say 80. Then we say, oh, average for all is also 80. But this sounds not so good. We say we cannot believe you. Maybe so more reasonable estimation should be x bar along mu will be in some interval, right? So it's an interval estimation. Okay. Okay. So we call those interval as confidence interval. So those stats we already know, right? So we have a confidence interval. Okay. So for confidence interval, we also have these two cases. Like we sometimes use z, sometimes use t. So here we have one sample z interval, one sample t interval. Okay. Okay. So saying like we use data. We say in many situations use data. The purpose is just to test some other people's claim. Other people say, oh, my medicine is really good, so we need to test, right? We just check some data to test their claim. So this is instead is called hypothesis testing. So we can test about the population mean, mu. Some people say mu equal this number, mu equal mu 0. So we will check whether this is true or not true. So test about the population proportion, percentage. Some people say percentage for all people is like p0 or like percentage. Let's say percentage is like 50% or 70%. So we will test the proportion. The proportion and the mean actually quite the same thing, but the proportion for percentage just we say the data is 1-0 data, yes or no. If you like do a survey, usually is a proportion, like percentage of how many percentage people like this product or like this guy. Okay, so make our decision. We will use p value, right? So p value. So what is p value? So p value. So if you taking statistics, stats 1, then you know this very well. We just check like for testing. Some people say mu is here, so mu 0 is here. But from our sample, we find the sample mean is here. So we just check whether this X bar and mu 0 is close or not so close, right? So close, not so close, based on this probability. So this probability is p-value. So if p-value very small, means X bar is far away from mu 0, right? So if they are quite different, then we can say, oh, mu equal mu 0 is not true, right? Okay. So we say for testing, let's say, like for hypothesis, like some people say this, some people say that. So how can we make a judgment? So we make a judgment is just make based on this likelihood. Who is more likely to be true? So if this guy has like 80% chance to be true, or that guy has only 30% chance to be true, then we just believe this guy, like 80%. Okay. So for test, we just check the likelihood ratio. So let's say, suppose this guy 80%, that guy 30%, so the ratio is 80 over 30. Okay. So based on this ratio to make our judgment. Okay. Okay. So instead, we have one sample problem, two sample problem, many sample problem. So here is quite the same, like as then we talking about. So how about the two sample? So the two sample, usually we will compare like whether there's two sample, they are quite the same or not the same. So we have like two sample z test or two sample t test or two sample z confidence interval or two sample t confidence interval. So confidence interval just so here we have two things that we can do with the data. We can do estimation, so those just interval, confidence interval. We can do estimation and do testing, right? So z test, t test means the data follow normal or follow t. Like those test statistics follow t distribution or normal distribution. Okay. Okay. So paired data means like we can change two sample problem to one sample problem, right? So if the sample size is same, we can change this, like we say, like for example, we wanted to compare class 1, class 2, so we can just check like this, class 1 minus class 2. So we get one sample data. So we can change this two sample problem to one sample problem. But in this example, like class 1 minus class 2, this makes no much sense. Like because this first student can minus this student can minus that student, right? So how can we do this minus or subtraction? So usually in this example, this class 1 minus class 2 make no sense. But sometimes we can do those things. Like this minus data 1 minus data 2. So typically, for example, like if let's say we can say like for this and this the same people, this like we say uh, take before taking medicine, then then after taking medicine. So this number minus this number, that makes sense. Like this means there's a person's information or person's in health index before or after taking this medicine, right? So sometimes we can do those things. Okay, okay. So here we also can have population or two population proportion P1 P2, so mu1 mu2 two population means of two proportion. So here we sometimes we put estimation or test, we just call those things as inference. Inference is just information. Okay. Okay. So if data is quite big, then if we use computer, we actually we don't need so much technology. We just use this computer method called bootstrap method. Okay. Okay. So if we compare many group, then we use ANOVA. So ANOVA is analysis of variance. So compare many groups, we use ANOVA. So this ANOVA, so we call single factor ANOVA. Means that we can there's several groups, we can separate those several groups just by one factor. For example, let's say like this take just medicine, we just compare several medicines. This group take medicine A, this group take medicine B, this group take medicine C, or this D, or like that. So here we split all the people by this medicine. So medicine is a fact, the single fact. Okay. So how about two-factor ANOVA? So this means we should separate people, or separate by two factors. So for example, like separate here by medicine, like A, B, C, D, E. And we also can split by gender, let's say male or female. Okay, so we can have this, like, okay, so those data is like those people, male patient take medicine A, so result is here. So those male take medicine B, result medicine E. So here female, some female take medicine A, some female take medicine B, like that. Some female take medicine E. So this is two-factor ANOVA. Okay, two-factor ANOVA. Okay, so let's say what means without replication. So just like here, like this guy, this male take medicine just once. If take this medicine twice, like here, first day, like second day, like this. Okay, so this is two-factor ANOVA with replication. We'll repeat. Okay? Like each patient take a medicine several times, just like that. Okay, so we have two-factor ANOVA. Okay. So here we have, let's say, we have we can say here we have many we have many groups, many samples. We can call it compare many samples, right? Okay. Or we have many different peoples. Okay. But sometimes one person have many variables. So we an example, the student, let's say this guy, like let's say student 1, student 2, student 3. Okay, this student, this one person. But in order to describe this person, we have many variables, or gender, or this guy is male. Okay, let's say this guy is a female. Okay, so gender, right? Or exam 1 score, this guy 90, or this guy 80. Okay, and then other things, right? Or this guy's weight, height, or this guy's final exam, ACT exam, or etc. So here, one person have many variables. So we need to check whether those variables have some relationship. So those are regulations. So simple linear regulations, just this, whether this one related to some other variables, like equal x1 or x2 or x, like that. So linear means this function is a linear function, right? So simplest function is linear. Okay. So for regulations, we have two things. One is find if the linear relationship, find the coefficients, right? And then we will check whether the relationship is, whether this y related to this x, or the coefficients can be 0 or cannot be 0. So we wanted to estimate or test. So we wanted to find some information or inference about this beta 1. So we also can have find like some other things, like we can check inference for, like for example, mean response. What is the response means? Like if we, so here if we believe y related to x, so if we know x, so we can estimate this y, right? So we can find, we can find an average. So we call this average is a mean, like mean. So response is y. Okay, so correlation, those things are just the correlation. Those things are just as usual. If we have two variables, we can check a correlation, right? So this y related to x1, or we can check a correlation with y or x1. If they have correlation, then we can say these two things have some relationship. Okay. Okay. So then we will check whether this relationship is significant. So we can, let's say, analyze those residues. So residue is just the true y minus supposed y, we say y minus y hat. So by analyzing those things, so we can check whether the relationship is significant. So basically, like if those numbers really very small, then means expected value and it supposed observed value match very well. So this means our assumption of this relationship is significant, right? So if this residue, the difference quite big, y observed y a true data and your estimated data differ very much. So then this means your estimate is not so good. Okay. Okay. So instead we have a one-way table, two-way table. So those are chi-square tests. So here we will explain why those are chi-square tests, where the chi-square come from. Okay. Okay. So chapter 14 is non-parametric method. So what are those meanings? We have a parametric method. Oh, let's say. So suppose the data, we have data like those numbers, right? So we assume those data that come from a normal distribution. So we know those data come from normal distribution. So only thing we don't know are mu and sigma. So mu, sigma, those things we don't know, right? So we just wanted to, based on this data, we just wanted to estimate mu and sigma. So those method is just parametric. Parametric method. So this was come from, we say, like a populations suppose populations things, population information. We call the population information as the parameters. Okay. And suppose the data, so sample. We have those data. So from data we can find those sample mean or sample standard deviation. So we call those things, anything from sample, as statistic. Okay. Okay. So but anyway, like here, so parametric method means we assume something. We only don't know those parameters. Like we assume this from normal, or we assume this from exponential distribution. So only thing we don't know is beta, this coefficient. Or we assume this come from gamma distribution. We only don't know those parameters. Okay, so those are parametric method. So then sometimes like once we have data, so how can you, so we say, how can you assume those are normal? We have no idea, right? We cannot assume this is normal, okay? So then we just, let's say, so without this, we don't need, we do not have those assumption, right? So we wanted to estimate something or some like some other things. So we call this the non-parametric method. Okay, so we can, let's say, we can find, let's say, from data, let's say, we can find, estimate this function. Let's say distribution density, cumulative function, right? Let's say we suppose this function, we call this is a cumulative function, right? This landing variable x less than this typical number x. So if we have this data, we can do those estimation. We just check, oh, totally how many number, n number. Among those n numbers, how many less than x, or we say that 5, like that, like. So, but anyway, like we call those as non-parametric method. Okay, and the last one is Bayesian estimation. So we have prior and posterior distribution. So what is Bayes? Okay, this we have a Bayes. Let's say find a probability. We have this, like, okay, we have this formula, right? For PA check prob. So PA means we just check all people, right? For check all. So we, okay, so suppose we split it all into parts. So this is B1, this is B2, this is B3. We split all people into 3 parts. Then we have this formula, PA for all, so equal, we just check B1, then for B1, what these things happen. Okay, then like suppose A is not, A is a bad thing, okay, really bad thing happen. So this is the probability for A. What is the chance some bad thing happen? So we say the equal PB, this part B1, then B1, among those people, this bad thing happen. The plus B2 and B2, this thing happen, right? So we have this formula. Okay. So from here, so here we have 3 parts. So this 3 parts, so we can say that there's a part for B1, there's a part for B2, there's a part for B3. So what is we want to find? There's a probability. So this thing happened, bad thing happened. We want to find what is the probability that this bad things come from B1. So we say we have this formula, right? So PA so equal. So PA is 3 parts. Then among the 3 parts, this part over 3. So let's say, so here we have 3 parts, right? Plus this, we have 3 parts. Then PB2. Okay, so this is probably from B2, right? So which is this part of total. So we call this is Bayes formula or Bayes theorem. Okay, so this is like here we have some information. Already we know the bad thing happen. So then we want to find the reason. So for estimation, if before we have no information, then we want to estimate. So afterwards we have some information, then we will use those information to do bad estimation, right? So we have those estimations, Bayesian estimation. Okay, so those are let's say so it's an overview for our this class. Okay. So I hope you find this course is easy and interesting. Okay, and also useful.